certificate. After the tarpaulin is opened, an identity check of the contents takes place. 2 big bags are taken to a test room. The tester puts on protective clothing and an externally ventilated Raycol helmet. After opening carefully, the mercury level is measured. A retain sample is then taken. Screw-top jars are filled on location just as they were in Bitterfeld. The readings and the sample taking is documented in the daily report. The retained samples along with the daily report are transported to the in-house laboratory by lift. Here, precisely 4 grams of waste material are extracted from the samples and subjected to an X-ray fluorescence analysis. The high mercury level is clearly noticeable. The pH level is just as precisely determined. 100 grams are diluted with distilled water. The measured reading is 8. This is alkaline. Important because there is a strict separation of the disposal of materials reacting to acids and alkalis in the underground waste disposal plant. The results are printed out, documented, and receipted on the consignment note of the retained sample. An identification label is printed out and pasted on the retained sample jars. Naturally, all the measured data and the results of the entire analysis are documented on the computer and recorded on the accompanying documents. We now have the retained sample consignment note, the daily report, and the acceptance control list. An internal analysis of the composite samples enables us to compare them with the sample data determined in Bitterfeld. If the readings are correct, the laboratory gives the go-ahead by phone for the transporters to be unloaded. The disposal process takes its course. The underground waste disposal plant container moves in and is loaded with the big bags. The route card is put in a box outside the front of the container. The container is now on its way to the main shaft. Here it is unloaded and taken to the main shaft. In just a few seconds, the contaminated dismantled material will no longer exist above ground. It disappears from the face of the earth. We go with it to a depth of 700 meters, where 550 million tons of potassium salt are deposited. Our container is transported underground by a special shaft and loaded onto a special vehicle. We can see the consignment note. Then the red light comes on and off it goes. Potassium salt was mined here until 1984. This created some 7 million cubic meters of mined cavities. We're on our way to a segment of the used depository area with a total volume of approximately 4.6 million cubic meters, enough to store more than 2 million tons of hazardous waste. Our container has arrived. We can see the bunker-like site where the big bags are stored. Above us, salt, overlaid by thick layers of clay, which allow no water to penetrate. This dry mine is a prerequisite for the storage of waste. Unlike the disposal sites above ground, there are layers of water above us. This means we are always able to protect waste from the biosphere thanks to a natural barrier. Even underground, the scene is clear. The consignment note is delivered, and then the material is unloaded and stacked up to the salt ceiling. The yellow sample case is also delivered. It is then taken to the room where the retained samples from all the hazardous waste stored here are archived. The consignment notes are checked, receipted and filed away. Then the test jars are put away. A transparent documentation system, safe and traceable by anyone, right back to where the hazardous waste was collected. The storage chambers are walled in. This is a further technical barrier to secure the hazardous waste. Whether in drums, special containers, or as here, in big bags. Now let's take another look at the control room for the underground waste disposal plant. Here, the hazardous waste consignment note, the internal route card, and the daily report are amended, signed, and filed away in the underground archive. The empty container goes back to the main shaft. Here, once again, we see the steel safety doors that separate the waste disposal plant from the normal mine. We now leave the hazardous waste secured behind us, knowing that we all have one less worry. Mid-March, we're back in Bitterfeld. The buildings have all been dismantled. Now comes the removal of deeply embedded debris and the soil extraction to a depth where there are no further traces of mercury contamination. At outside temperatures of over 10 degrees Celsius and bright sunshine, mercury bubbles rise from the ground. With special apparatus and under strict safety precautions, the mercury is vacuumed and caught in a collection container for removal. Highly contaminated piles are covered to prevent emissions. The site is sprayed with water. Soil extraction is carried out according to designated grid squares. Once again, real logistical expertise is evident. Everything is documented to show which piece of chlorine-3 is moved from where to where, when and by whom. Precise, safe, traceable. After decontamination has been carried out, an evaluation of decontaminating objectives takes place. This proves the success of the decontamination process. The corresponding documentation then serves as proof for the next user that this area is decontaminated. A view of the dismantled chlorine-3 site. We have witnessed the reclamation of a plot of land thanks to the services of 3 companies. The engineering expertise of Bizantec Nova in Bitterfeld. The experience of dismantling specialists at Plambeck Contracon in Leipzig. And the disposal services of K+S Ensortung in the underground waste disposal plant in Seelitz. This represents a responsible interaction with our environment.